then log base 4 of x. How would you graph that one? That's all the x. Remember, there are those 3 points that we will use to graph the log. So today what we're going to do is we're not going to graph exponentials. We are going to graph logarithms with transformations. That is our only goal for the day. Some of you probably feel like you don't mean stop it right now, but so here's an example. And I want to graph all of these things. What do you notice the base function is for all 4 of these functions? Log base 3. So before I do any of these, I'm going to graph log base 3. There are 3 points that I can find on a logarithm to help me graph a generic logarithmic graph. What are those 3 points? 1, 0. How do you know 1, 0 is on there?
It's always on there.
It's always on there. 0, 1 was on an exponential, and we switched the x's and y's. The base, which is 3, 1, and 1 over the base, -1. So 1/3 -1. You could continue to plot points if you wanted to, but that gives us the base graph of a logarithm. Remember, it does have a vertical asymptote at x equals 0, so be careful, make sure it exists. So what am I going to do for the one graph? Pick it up and move it right through. Is this still new?
No.
I hope not. It's just things you've done before, just with a different original. Pick it up and move it right through. Now, when I did this with exponentials, you remember I moved the asymptotes. You remember that? I want to do the same thing with logarithms. So this time the asymptote that I'm moving around is a vertical one. So that y-axis, when I shift left or right, I'm going to move that asymptote. Do I have to move it if I shift up or down? No, because that one's not going to move when you shift up or down. This one shifts up or down. Any questions about that one? Okay, red one. What am I going to do with the black graph to get to the red one?
Down 3.
Good. And left 2. Down 3 and left 2. When I move left, I am going to pick the asymptote up and move it so that I don't cross that asymptote. I'm going to move it left 2, down 3.
That one is the original, and then that's just log 3.
Log base 3. And there are 3 points I know on log base 3. When you watch the video, you'll see where those are.
Wait, can you wait, please?
Yes. A logarithm is the inverse of an exponential. So were you here when we did this? Okay. We plotted points. Anything to the 0 power is 1, 4 to the first power is 4, 4 to the -1 is 1 to 4.
Okay.
So that's where I got this. Log base 4 is defined to be the inverse of 4x. So we learned that yesterday. Watch that video because it really takes. Y'all agree you took a lot of fear out of logarithms yesterday?
Yeah.
Made them not so bad. So we switched all the x's and y's. And so this red one is log base 4. That's easy. Alright. What is the negative of the logarithm do? Reflect on the x-axis, and what does the +2 do? Moves it left 2. So the asymptote will be the same as that one. We're going to take the black graph, reflect it over the x-axis. So this point moves down here, and move left 2. When you reflect at the x-axis, what happens to a point that's on the x-axis? It doesn't go anywhere, right? So it stays there and move left 2. This one moves up. Everyone agree?
Yeah.
And left 2. You can do multiple steps on that. say green graph? Reflected and moved left. Reflect first, then move left. Any multiplier you do before you shift. Right? Why? Please excuse my dear. Yes. When you multiply before you add. Okay, the last one, what does the 2 in front do? Vertical stretch and multiplies all the y values by 2. So, this y value is negative 1. What's negative 1 times 2? Negative 2. So that point moves down here. What's 0 times 2? It's still 0. And what's 1 times 2? So you kind of see it stretches it out. The purple graph is the graph multiplied by 2. This is what your homework looks like. One thing that you need to know that textbooks aren't always real good at explaining, so I want to make sure you do know that. If there are no parentheses shown, then they only go with the thing right beside the logarithm. So if you ever see no parentheses written, then the logarithm only goes with the number that's right after. Does everyone see what I mean by that? To get the 4 inside, they would have to put parentheses around the x minus 4. Okay? So, write that in your notes. If there are no parentheses, what I would put in my notes is I would put this example, log base 2 of x minus 4, and I would put out to the side equals log base 2 of x minus 4. So that you'll know how to deal with the problems where they don't clarify which way that goes. Now that you see that, what kind of shift is there? Vertical shift, right? Vertical shift down. No reflection, no horizontal shift. Did you get it, Jeff? Okay, vertical asymptote. Has this been moved left or right? If it hasn't been moved left or right, then what's the vertical asymptote? 0. But I'm going to go back and graph it if that's okay with you. It is log base 2, so my original graph, what are the 3 points on my original? 1, 0, 2, 1, and 1/2 negative 1. So that black one's my original. And I'm going to shift it down 4. Notice when I shift down, the asymptote doesn't move because it was a vertical asymptote, so vertical asymptote when I shift up and down doesn't move. What would cause that vertical asymptote to move? Left. Got a horizontal shift. What's the domain if it's not shifted? 0 to infinity. Why 0 to infinity? Because I don't have anything to the left of the vertical asymptote. So first x value is 0 to infinity. What is the range of any logarithm? And is this increasing or decreasing? Increasing. What would change a logarithm to decreasing?
Negative.
Right? Some sort of reflection, right? Either reflection would do it. Let's get that a little harder. Here we go.
Yes, there.
Oh, just that thing. There we go. Still not real hard. It is a natural log. So that was your request. Let's do a natural log. Got a couple of things going on. If I don't do an example in class today, remember to be careful if there is a negative and a horizontal shift. It makes your horizontal shift work backwards. I don't know what I mean by that. Instead of right, it would move left or right. So, about 2.7. If you forget that, type it in your calculator, find out it's about 2.7. So, what are my 3 points on the original? 1, 0. 2.71. So that's not going to be a perfect spot. It's 2.718. But it's about 2.7. Would you agree 2.7? If I do 1 over that, it's going to be somewhere between a half and a third. You're probably not going to be able to tell the difference on your graph anyway. But it's a half right there. Anyway. We'll just estimate the best we can. So this is our original natural log graph. That's the first transformation I'm going to do. The reflection. Remember to do multipliers before I shift. So this is reflected over what? So we're going to do that first. I'm going to show these in multiple steps. So the blue one is reflected. On your homework, you do not have to show multiples, but it is okay if you do. If you do show multiples, let me know which one's the final answer. An arrow to it, or use a highlighter, or something creative. Now I can horizontal shift and vertical shift. Which way am I horizontally shifted? Right 3 and up 1. I'm going to do those in one step, but when I move right 3, what am I also going to pick up and move besides vertical asymptote? So I'm going to pick that up and move it. I'm going to pick the blue graph up and move it right 3 and up 1. So the red graph is my final graph. Where is the vertical asymptote? X equals 3. What is the domain? 3 to infinity. Why 3 to infinity? Good. The vertical asymptote is 3. Remember to find domain. Take your pencil and put it vertically instead of the left-hand side of the graph. Do I touch the graph out here? No, 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 no. Where's the first place I touch? At x equals 0. So, red one. X equals 0. And it's right after 3, so I do parentheses. What is the range of every logarithm? Give me the answer for -6. And the red graph, your final graph, is it increasing or is it decreasing? Decreasing. On your homework, if having the multiple graphs on your paper confuses you, what could you do? You can erase them until your final. And what about you didn't get it. You got it. And the top one. And no.
Okay. There's one that didn't have a name. There's a couple. I think it's Gabe. Just looking at the handwriting, but
Okay.
I'm not sure. I didn't know what to go.
Yeah. So it's his hour.
Yeah, it's 6 hours. I think it seems like I was looking at it, and I think this is most likely Gabe's.
I'll ask.
But I don't know how Walter writes.
Yeah. I will ask.
I think I remember like that was in. I part of it.